Choosing an AI agent framework in 2026 is an irreversible architectural marriage. This decision locks your logic into a foundation you'll live with for years. Stringing together raw API calls is a tempting way to start. It's cheap and works for a single tool, but it lacks the state persistence and human approval gates required for a scaling system. This structural oversight is the primary reason Gartner predicts that 40% of agentic AI projects will be canceled by next year. These failures are expensive. One fintech agent hallucinated for 11 days and racked up $47,000 in API costs before anyone noticed. Without auditability and pause states, you have no way to stop an agent that's burning cash. Developers are forced to navigate a severe trade-off. You must decide between the speed of building a prototype and the deterministic control needed for production. This chart maps the 2026 landscape by plotting ease of setup against deterministic control and auditability. CrewAI occupies the bottom right corner for fast, low-control builds. LangGraph sits on the opposite end, offering maximum control at the cost of a much harder setup. We will map these 8 frameworks to specific engineering profiles to help you avoid a costly, multi-month rebuild. Selecting a framework that looks good in a demo but fails in a real-world edge case will force you to rip out your entire architecture in 6 months. The Rapid Prototyper profile describes teams that need a working multi-agent demo by Friday. CrewAI fits this profile by allowing you to define agents through abstract roles, goals, and backstories, rather than strict programming logic. This approach delivers a working system in 2 hours. However, the execution is non-deterministic. Latent delays of 20 minutes are common on the enterprise platform, and the decision paths are often untraceable. The regulated enterprise profile is the opposite. These teams operate where silent errors create massive financial liability, and auditability is a legal requirement. LangGraph supports these requirements by modeling workflows as directed graphs. Every step is a node, and every transition a rigid edge. This structure provides transparent state control and time travel debugging. It also reduces inference costs by up to 50% by skipping repeat calls. The engineering tax is significant. Using a graph-based architecture is complete overkill for basic automations that don't require high-level branching. Prioritizing initial build speed sacrifices the deterministic tracing you need to survive late-night system failures and real-world edge cases. Deploying autonomous AI agents in high-stakes domains like healthcare or finance requires precise control over data and decision-making. These systems require ethical governors and tiered autonomy. This architecture mandates that a human sign off on any high-stakes decision before the agent can proceed. Without active mitigation, AI models inherit and amplify the historical biases found in their training data. This table shows performance before fairness techniques. The model shows demographic bias, over-predicting male income at 75% compared to 55% for females. Applying a reweighing technique improves these metrics, bringing updated predictions of 72 and 62% closer to the baseline. This confusion matrix illustrates the model's actual classification volume. Optimizing for group fairness fundamentally shifts how the model distributes its correct and incorrect predictions across the dataset. Inserting these human-in-the-loop checks and bias audits adds friction to the workflow and slows down pure autonomous speed. Production readiness requires accepting a slower, governed execution loop to avoid the legal liability of a biased autonomous system. The ecosystem loyalist profile applies to teams already committed to Azure, Google Cloud, or Anthropic infrastructure. The Claude Agent SDK relies on deep model context protocol integration. It allows agents to perform sandboxed file editing and use sub-agents as modular tools. Choosing a provider-native SVT creates absolute vendor lock-in. You lose the ability to swap to cheaper models if your provider changes their pricing structure. Microsoft's semantic kernel offers native C# and .NET integration. This is the most practical path for organizations with heavy existing enterprise IT infrastructure. The trade-off is momentum. By staying in the .NET ecosystem, you miss out on the rapid open-source developments happening in the Python community. For the data-centric builder, retrieval is the primary bottleneck. If your agents spend most of their time reasoning over massive document stores, Llama Index is your best option. Llama Index provides unmatched data connectors and document reasoning, but it is less effective at managing complex negotiations between multiple agents. Your existing enterprise contracts and data architecture should disqualify half of these frameworks before you write a single line of code. You must now move from evaluating abstract framework features to assessing your specific engineering reality, mapping these choices directly to your actual daily production constraints. Start with your primary bottleneck. If your system relies on retrieving and reasoning over complex data, branch toward Llama Index. If you need a working multi-agent proof of concept to get stakeholder approval by the end of the week, choose CrewAI. This path secures fast buy-in, but expect a complete architectural rebuild if the project requires strict governance. If you are building in a regulated space that mandates audit logs and explicit tracing, choose LangGraph. LangGraph requires a difficult first week of architectural planning, but guarantees a system that survives real-world users. Stop treating AI agents like a black box. Abstraction becomes a massive liability the moment a hallucination costs your business real money. Use LangGraph for production systems and CrewAI for hackathons. Commit to native SDKs only for a marriage. Prioritize the framework that minimizes your long-term architectural regret. Your system must be able to withstand the scrutiny of real-world audits and edge cases.